Good afternoon, and thank you very much for allowing the time to join us today. My name is Charles Scott. Welcome to this month's Civil Designer Software Open Classroom webinar, our 76th in the Open Classroom webinar series. Today, I'm going to be joined by Andrew Cole for an advanced session specifically covering our sewer module's geometric and flow control conditions, as well as an in-depth look at sewer property connections with some troubleshooting tips. For those of you new to our sewer or foul water design module, please visit our FAQ page on our website www.civildesigner.com and browse through our library of short voiceover FAQ videos where we cover a wide range of related topics from creating a sewer project from scratch to automatically creating 5,000 new house connections in 180 seconds, moving on to calculating comprehensive quantities, and then contributing all of this information to any BIM workflow process. Back to this afternoon. During Andrew's presentation, please feel free to use the text chat service on your GoToWebinar app or webpage to ask us any questions you may have during his time. After today's webinar, we'll be posting a video copy of the event on our website in the webinar section for your further review. And by Monday, we will have posted the searchable FAQ videos created from this webinar in the section we have just visited, the FAQ section. So, Andrew, welcome back. It's been great working with you again. Please take it away.
Thanks, Charles, and welcome everyone to this month's webinar. In today's webinar, I'll be looking at Civil Designer's sewer application, and we'll be answering some of the frequently asked questions we get regarding the settings that can be set in the sewer design parameters, as well as looking at some issues that can pop up when analyzing your earth connections. Okay, so I'm starting off by opening up a sewer project. And in this case, I've intentionally deleted the SED or sewer defaults file so that you can see that we have now added an option to load your own SED file or alternatively load our default SED file, which has all the necessary defaults written into it. So the yes option here would be to search for the file, the SED file in a folder. The no option is to use the standard default file. These two options are available when you are adding a new sewer file to your project settings, while setting up a new sewer project, as well as when opening an existing sewer project and the program then cannot find the required SED file in the same folder as the SE8 sewer file. Previously, you would have to copy and paste the correct SED file into your project folder, but now you get prompted to either search the yes option for the missing file, or you can then select no to load the standard default file. So in this case, I'm selecting no. Okay, now that we've opened the project, we can have a look at those sewer design parameters settings. Just changing to the sewer application, going to the edit menu and the design parameters. So I'm going to be focusing in on these geometric controls, the minimum drop distance, the enforcing of your maximum link slopes, and then the flow controls. We're going to look at the using of the full bore velocity in your calculations and the dynamic inflow update. But starting off with the minimum drop distance. So if I put my cursor over there, you'll see the minimum level difference for implementing a drop in a manhole. Okay, and then just going to my hub file. If I press F1, remember with the dialog open, I can also read the minimum drop distance from the hub file. This is the web-based hub file. Okay, so just to clarify there, the minimum distance between the manhole invert level, where you're trying to implement the drop manhole condition, and the outlet level of an incoming culvert to apply a drop inlet at that manhole. Okay, so it's the minimum distance, that level difference between the manhole's invert level, where you're trying to implement it, and the invert level of the incoming culvert at that manhole. Okay, so let's just have a look at that. Okay, so the default is 0, which means there's no required level difference, so it'll still implement it if it's set to 0. Okay, so let's have a look at how it works. So I want to implement that drop manhole on this manhole, yeah, the drop manhole condition. Just selecting the link, right clicking, going sewer operations and edit long section. I need to run an analysis, but let's have a look. Okay, so essentially we want to implement the drop manhole over here. So let me change that. I'm going to select the manhole, and then here in the properties bar for this particular manhole, changing the manhole condition to a drop. Saving that, close the dialog. Okay, then let's just have a look at those levels. So I'm going to go to display settings, to my nodes, and entering a new, I want to add the invert level. Okay, so IL equals, I'm right clicking from the automated annotation, selecting the invert level. Okay, so currently if we look at the level difference over here, 89.394, so that's the upstream manhole, and then 87.572. So we're looking at in the region of 1.8 meters, this difference between those two. Could quickly do calculator just to check it exactly. So it'll be 89.394 less 87.572. Okay, so 1.822. Okay, that's the level difference, but then we also need to factor in the slope over here. So we probably have to work out the fall from this manhole to that manhole over this distance at your maximum slope. Let's just have a look at the link tables then. I'm going to go to link types. We've got a UPVC pipe. And if I go to the sizes, you can see your minimum maximum slope. Okay, so I'd imagine in this case to reach cleansing velocity we're using maximum slope, so 1.25 percentage slope or 1 in 80 ratio slope. Okay, so let me just go back to my calculator again, and I'm just going to do that quickly. So it's that distance of 20.838 multiplied by that 1 in 80 slope. So it's about 260. Okay, so we had 1.822, and we want to subtract. Let me just go. Okay, so we're looking at 1.562. 1.562. Okay, so that's more or less the level difference we're looking at. Let me close that. Okay, so let's try it out now. So I'm going to set my parameters over here. So I'm going to go to edit design parameters. I'm going to set it. So let's go to 1.6. Okay. So if I set it to 1.6 and I run my analysis now, it shouldn't implement that drop manhole as yet. Just closing that. Just going to clear my selected sewer entities. I'm just going to go to the vertical alignment. And we can see over here it hasn't implemented that drop manual because we've taken this level over here, we've taken that level, worked out the level difference, and we've factored in. You can see the slopes over here 1.25 percent, so it's all at 1 in 80, which is our maximum slope. So you have to factor in that fall from there to there, so it's going to be the incoming culvert's level at this position down to there, so that's that level difference we have to consider. Okay, so going back to my design parameters, and this time I'm going to make it 1.56, which gives us 2 millimeters to spare. So let's see how close we get to that. So if I run my analysis now again, network, so that manual is set to a drop, but the question is, will it implement the drop manual? So let's have a look. Tools, vertical alignment, and voila. So if I select on that manual now, you can see there's that drop that we worked out. So 1.562 is the actual drop. I've set it to 1.56, so it's more than that required level difference. So it's implemented the drop manual condition. Okay, so hopefully that explains that minimum drop in the design parameters over here. Okay, I'm just going to set it back to 0, which allows you to always implement that drop manual irrespective of the depth. Okay, so the next design parameter setting that we're going to look at is this enforcing your maximum link slopes. Okay, so let's just have a look at that. If we go to edit the link types, just to view in this link table for our UPVC, under the sizes tab, you've got your minimum maximum slopes. Okay, so the minimum default slope is 0.5%, which equates to 1 in 200, and then maximum 1.25%, which is the 1 in 80 slope. So these are just the defaults. If need be for your design, you could always change the minimum maximum slope, but the program is always trying to stay within that minimum maximum slope envelope. Okay, so let's have a look in the vertical alignment for areas that we might be exceeding our maximum link slope. So on branch 1 over here, 1.25, so we seem to be okay on branch 1, and then let's have a look at branch 3. Okay, so branch 3 over here, you can see this initial slope on this first link is getting quite steep, 6%, which is getting close to 1 in 20 slope, so very steep over there. The reason for that, there are two main reasons that your system might exceed, the links might exceed your maximum slope. The one is minimum cover. You can see in my display settings for the vertical alignment, I've got the show minimum cover checkbox checked, and that's that green line over there. So for this manual, we're making sure that you've got enough cover that your system doesn't daylight. Okay, so that's your minimum cover, and then the rest of the branch over here is fine, 1.25. Let's just have a look if there are others. Okay, so this link over here getting a bit steep as well, getting close to 10%, so 1 in 10 slope. The other reason that we do exceed, the program would exceed the maximum link slope, is to tie into another branch that's running a lot deeper. Okay, so this one as well getting a bit steeper than maximum to get to that minimum cover line. So the one is to tie into deeper lines when a branch ties into another branch that's running a lot deeper, and then the minimum cover. Okay, we could see that on that branch 1. Remember, this was where we implement the drop manual previously, but that was getting very steep. That was from manual 7 to manual 8. So it's this area here. So this is the branch running a bit deeper. You can see those levels there, 87. This one's coming at 89. So this was a lot higher. The terrain's higher, and then from there it's dropping in to tie into that branch over there. Okay, so just the two main reasons is tying into those deeper branches, collectors, and then that minimum cover is the other issue. So making sure we got minimum cover. Okay, so how do we prevent the program from exceeding the maximum link slope? So that would be going to that design parameters and checking this enforce maximum link slope. Okay, you get a message there. This option will change the manual condition of the upstream manual to drop. Do you still want to continue? So yes, we do in this case, and okay. And then we can run our analysis, analysis network, just normal analysis. Okay, so let's view that in the vertical alignment. If I scroll now to branch 2. Okay, so you can see now the program is implementing the drop manholes automatically. Let's have a look at that. Branch 4. Yeah. Okay, if I zoom in, so that was that first one. So it's 1.25. So we haven't exceeded the maximum link slope. And the program then automatically inserts drop manholes for us. Okay, so that was that design parameters and enforcing your maximum link slope option. I probably need to mention that I've been going to tools and the vertical alignment to view the links that are exceeding the maximum slope. But you could also view that under results, so your analysis results, under the link layout tab over here. Okay, so when you run your analysis, you'd get the results, and we flag in blue any link that is exceeding the maximum link slope. The moment they're all fine because we ran that enforce the maximum link slopes in the design parameters. Let me just run it without that enforcing the maximum link slopes again. If I run an analysis now without enforcing those maximum link slopes and look at the link layout, you'll see we flag in blue any link that's exceeding the maximum link slope. So you could always view it there after a normal analysis. Like to view it in the vertical alignment just to get a picture of what's happening in the design, but you can actually see it in the results as well. Okay. Alright, then having a look at some of the other design parameter settings. Moving on to these flow controls. Obviously something to set initially would be your minimum cleansing velocity. The default being 0.7 meters per second, but you can edit that if necessary. We're mainly going to be focusing on this use minimum full bore velocity in calculations. Using the full bore analysis can result in a much more economical design. Okay, so let's just have a look at that. Okay, so just opening up this drawing that I've done to explain the full bore analysis. So when setting the full bore flag, that means that the velocity is calculated as if the pipe was flowing full, as it is normally slower than the pipe flowing at say 60 or 80% full. However, the pipes will be sized according to the maximum flow depth. Okay, so full bore, remember full bore actually means the pipes flowing at full capacity. When using the full bore analysis, we calculate the slope required for that cleansing velocity, minimum cleansing velocity, based on the full bore flow. And then once the slopes are set, we will then use the actual maximum flow depth to calculate the required pipe size. Okay, so the main purpose of the full bore analysis is to prevent those steep initial slopes at the first few links of a branch, which don't have that much inflow coming into them as yet, and that would generally push the whole system a lot deeper. So the full bore analysis is very useful, and as I said, makes for a much more economical design. Okay, so let's just try that out, the full bore analysis in our sewer project. I think firstly let's have a look at the results. So if we look at the current analysis results, you'll see under full bore over here there are one or two links that don't have the required 0.7 meters per second cleansing velocity. So if we then go to our design parameters, check the use full bore velocity checkbox, and then run the analysis with the full bore activated, and then look at those flows. You can see here in the full bore velocity column we've got cleansing velocity for the whole system, that 0.7 meters per second cleansing velocity that we need. Okay, so that was the full bore analysis. Let's move on to the next item in the design parameters. That's that dynamic inflow update. Okay, so the dynamic inflow update has to do with the inflows from your earth connections. So that if it's not checked, you'll see over here, if I go to the earth connection default, you can't actually specify an inflow class or number of inflows in this dialog. So if you activate the design parameter, that dynamic inflow update, then as you add your earth connections, the inflows get added to the system. So traditionally, we could specify at a node you have 10 middle income inflows coming into this node, but with this system now you can add your inflows per property connection, per earth connection. Okay, so if I go back to those earth connection defaults now, you'll see that I can now specify an inflow class over here. You can see with the new sewer defaults, that SED file that I've used, we've got quite a nice list of inflow classes. So you can set your inflow class initially in your earth connection defaults. Okay. Alright, so to finish off today's webinar, I'm just going to have a look at the earth connections. I'm going to add a few earth connections, and we'll have a look at the acronyms that they use when they analyze and check whether your earth connections can drain into the main sewer system. Okay, so I'll be starting off with in the road reserve earth connection. So let me just zoom into that area on my site. I'm going to be doing some earth connections down here. I'm just going to go to graphical mark and clear. Okay. So I'm going to add earth connections. So ideally when you're adding earth connections, just before you do a run, just check your earth connection defaults. In this case, I'm starting with the in the road reserve sewer position, and then we could do an inside and outside earth sewer position as well. But obviously you need to set all your default settings, the earth connection defaults, correctly. We're also selecting to calculate the minimum ground level on the earth. So ideally for that, you want your CAD line work to be very tidy, and those lines should be connecting correctly to do the search inside that property. So the program would then track around the perimeter and then pick up the lowest level inside the earth boundary. We have got that snap and clip tidy function in the CAD application under the tools menu to tidy up your cadastral drawing. Okay, so let's add that earth connection. So I'm going to the earth connection menus and add earth connection. Okay, then just read your prompts, add your earth connection on the correct side of the sewer link. You can see we've got the elevation tracking, so you can check for your high or low point. Just following the contours in this case. So I'm just going to do F152, and I'm just going to type in EC152, and then just keep your eye on the prompt when you're adding your earth connection. So it's asking me to indicate the earth for the minimum ground level calculation. So I just have to click inside the boundary and I can save that. So it's the one middle income inflow class that I'm assigning. Then the function just repeats. I'm just going to do another one over here. So the number increments, you can see that, are 1 each time. Okay, so it's EC153, and then just keep reading the prompt inside, indicate inside your earth boundary. Once again, just a middle income. I can go to the earth tab and just, if it was something different, I could change, for example, my sewer position or those distances. And then I can just save that. And then I'm just going to right click and quit for now. You can see I've got the minimum ground level showing over here as well. So it's based on those contours. There's a high spot. So it's picking up the minimum ground level on that earth. Okay. Alright, I'm just going to do inside earth. So I'll change my earth connection defaults and change that to inside earth. Necessary, you can change these distances, for example, over here. Distance of your sewer, the main sewer line from the earth boundary, and then the distance of your connection, your actual property connection from the sewer line. Okay, let me just do that earth connection. You can also use the toolbar. Okay, accept. Just click inside, save that. Just adding one more inside the earth. Just increments by 1, and just click inside the earth boundary and save. Okay, and then I'm just going to quit for now. Okay, so I've done those two. Let's just go to display settings. I'm just going to switch on those earth connection, the earth number, so we can see. Just have to select a good position. Let's go make it bottom left. So it's identifying the earth connection number over there based on the earth number, and it's also identifying those low spots, the minimum ground level on your property. Okay, so we've done some in the road reserve earth connections. We've done where it's a mid block but the main sewer line's inside your earth, and then we need to do a few where the mid block is sitting outside the earth. So you'd go to earth connection defaults again, ideally, and change that to outside the earth, so the main sewer position outside the earth. Still using the middle income inflow class. Earth connection, add earth connection, and indicate the position. Just checking those heights. This is the low point. Just need to check the number. So this is 144. Accept, read the prompt, indicate inside for the minimum ground level point. Save that. And then I'm going to do 145, earth 145 as well. Increments by 1, so that's perfect. Okay, indicate inside. And for this one, I'm just going to escape now out of the function, just to show you how you can then relocate that minimum ground level. Okay, so let me run through the earth connection analysis. I'm going to run it quickly for those earth connections we've just added. So analyze earth connections, all of them. The not possibles are not being added to the system. So yes, I want to say that's fine. Okay, so a couple of not possibles, but I just wanted to show you the big issue here was that I didn't identify that property boundary, and you can see that in this big difference between the invert level of the connection, the property connection, invert level of the sewer. Okay, so in that case, just to identify that sort of issue, you can then go to earth connections and you can move the minimum ground level point. Okay, so if I click on that property or near the earth connection, it says indicate new position for the MGL. So once again, would then just position it based on the contours or the elevation tracking. Okay. The text there is overlapping, so I can actually select that text and move it. Okay. The same with this one. Okay. So something like that, you can move the text independently. You just select the earth connection, you can move that. Okay. So if I to analyze now again, analyze my earth connections. Yes, you can see that one's sorted now. It's just there's two not possibles, that earth 153, 154. Okay, so those not possibles are coming from the earth connection types over here, where we require at least 150 millimeters as the default between the invert level of your sewer, main sewer line, running past, and then the invert level of the connection based on your minimum ground level. Let's just have a quick look at that help file. Okay, just having a quick look at the help file. Remember, we're looking at the house connection depth, and we're working out based on a grade over here and a earth length. We're working out the invert level of the connection, and then the actual analysis of your main sewer layout, you get the invert level of your main sewer line, the ILS. Okay, so that E value is the height difference between the invert level of the sewer, ILS, and the invert level of the connection, the ILC. Okay, so traditionally that would be the main not possible that you'd be getting, is if that height isn't sufficient from the ILC to the ILS. Okay, which makes sense. You have to be able to drain the property into the main sewer line. Okay, so that's that ILC to ILS height difference. Okay, and we're flagging anything less than 150 as not possible. Okay, so how could we fix these two not possibles? Let me just have a look at that in the long section so we can see. If we go display settings, show crossing services, just selecting the earth connection. Okay, so you can see there earth connection 154, 153. Are those not possibles? So those are the two that we need to look at. So we can basically increase the minimum cover on that section. That should sort it out. Okay, we do have that auto update that'll fix it automatically. Update sewer levels, but I'm just going to do the manual method now. So I'm going to go graphical mark, and let's do everything upstream, replace. Okay, so I'm just selecting that portion of the network. Go to tool set parameters, and I'm changing my minimum cover over there. I'm going to make it 1.6. Okay, I would then have to analyze the network again. So all. And we can just have a look again at this long section to see what it looks like. Okay, so I still have to reanalyze. It's still flagging it as not possible, but I need to reanalyze my earth connections. So if I go back to earth connections, analyze earth connections. And there we go, all fine now. Okay, so that was just a quick fix. I could have possibly just gone to the manholes. So I could have actually gone to these two manholes, graphically edited the manholes and changed the minimum cover as well, just per manhole, just to do that particular section. Okay, but just to show you, that's the one way of sorting out those ILC to ILS not possibles. And then I just wanted to also touch on the other not possibles that you might come across. So to look at that, I'm going across to this project. If I run this project, analyze the earth connections, this one's got a whole lot of additional earth connections. Okay, I think there are a few not possibles which I've identified earlier, and one of them is that EC509. So the earth connection types is set to 150. Let me just check that. So for this particular project, earth connection types is set to 150. So let's have a look at those results again. I'm just going to select that portion here. So let's go graphical mark this branch, for example. And I can view the earth connection results just for that branch. Okay, so we're looking at that EC509. So the invert level of the earth connection to the invert level of the main sewer line is currently calculated is 177. So we shouldn't be getting a not possible on these two, on that 150 that we require. But the problem here is the moles to ILS. So this moles to ILS is a required check as well. So let's just have a look at that failure over there. So to do that, I've actually drawn a sketch over here. I know this drawing might be a little bit busy, but it should explain the not possible that we're looking at. The standard not possible is from the invert level of the house connection to the invert level of the main sewer line, which is this depth over here. But the moles check, the moles is the maximum or highest invert level that the main sewer line can have at the planned position of the earth connection. Okay, so this is a good check to place the sewer line vertically for a row of urban. It's a standard industry check. So the moles formula you can see at the bottom here, and it's basically that minimum ground level point, that level, the MGL, which the program picks up automatically when we click inside the earth boundary. Then we're going down the depth of the house connection. The DH in our formula would be to the bottom of the pipe, so it includes that earth connection pipe diameter. And then you have to calculate the level difference for the slope over the LE, which is the length of earth that you have to drain, and including the distance from the earth boundary to where the main sewer pipe is running. So it's the LE plus the A value in this case, which takes us to that point. Okay, and then we also then have to deduct the sewer diameter. The moles check for an earth connection inside the earth is slightly different. You'd have the LE and you'd have to deduct the A value, the distance from the earth boundary to the actual sewer, the main sewer line inside the earth. So deduct that A value. So the moles in ILC for an earth connection inside the earth, you working from the earth boundary, that LE length, you're working inwards. Okay, but in this case we're looking at a moles issue in a road reserve earth connection. So just to reiterate, the moles check to the ILS level the mils is the maximum or highest invert level that's allowed. So your invert level over here of the main sewer, as calculated by the analysis, needs to be equal to or lower than the mils invert level. Okay, so this is the highest or the maximum it's allowed to be, the invert level of your main sewer line. So just going back to this example over here, if we look at those earth connection results again, so the moles value for that earth connection 509, 176.948, and then the invert level of the sewer is 176.965. So in this case, the ILS, the sewer's invert level, is actually more than the maximum invert level that's allowed, and therefore it's got a negative value and flagged as not possible. Okay, so just something to be aware of. Okay, so once again, you could fix this situation by lowering the levels over there of that section of the network by increasing your minimum cover, for example. Okay, that brings us to the end of today's webinar. I trust that it was informative. Until next time, cheers, and back to you, Charles.
Thank you very much, Andrew. That was very interesting. For a video copy of today's webinar, please log on to our website's webinar page, where we will shortly be posting the link. Furthermore, by around midday on Monday, we would have posted the FAQ videos created from today's session in our website's FAQ library. As I stated earlier, if you're new to our sewer module, please go there now and view all our related sewer module videos, especially the video on how Civil Designer automatically creates 5,000 new house connections using our Earth Parcels functionality in around 180 seconds. And if you're new to the Civil Designer software suite, please feel free to enroll for our free 6-part introductory training course, accessible on our website's training page. Managers, this is a great service for onboarding new staff members. Once again, thank you very much to all of you for allowing the time to join us today. Please follow our company page on LinkedIn if you have not done so already for more information with regards to our customers' project showcases, industry-related news, and our new Civil Designer software tech tips. Have a great afternoon, weekend when it arrives, and goodbye for now.